Lesson 9-5 is all about rational equations. We've used rational expressions before, where both the numerator and denominator are polynomials, or they can have the variables in them. Now we're going to look at rational equations. Now, a rational equation just sets one rational expression equal to another. So key terms here: rational equation, an equation that contains one or more rational expressions. An extraneous solution is a result that is not a solution to the original equation. So you can think of it as a solution that is an excluded value because it makes the denominator 0. If we go through the whole process and we get an answer, but if you go back to the beginning and it makes one of our denominators 0, we call that an extraneous solution. We can't use that. Now note, when a rational equation is just a proportion, so one rational expression on each side, you can use the cross products to solve the equation, or just cross multiply. And we'll see that in our first two examples here. So example 1, we've got 4 over x minus 3 equals 7 over x minus 1. Because it's just a proportion, we can simply cross multiply these pieces. 4 times x minus 1 and 7 times x minus 3. When we do 7 times x minus 3, this 7 gets distributed to both pieces. 7 times x and 7 times negative 3. So it becomes 7x minus 21. The 4 times both of these pieces, x and minus 1, makes it 4x and minus 4. At this point, we want to move all of our x's to one side and all the constants to the other side. So we'll take away 4x from both sides. Minus 4x minus 4x. Those cancel out. And we have 3x minus 21 equals negative 4. Now, again, we want to get all our constants on the same side, so add 21, those will go away, and we're left with 3x equals 17. To get x all alone, we need to divide by 3 on both sides, which means in the end we're left with x equals 17 thirds, or, so if you want to keep it as a fraction, you can keep it as 17 thirds, or you can call it 5 2/3. Either one of those is acceptable. Now, because we have solved the equation, we need to check and make sure that 5 2/3 would fit into both of these ones. Now, according to this one, x cannot be 3, because 3 would make this 0. According to this one, x cannot be 1. This is neither 3 nor 1, so this solution will work. We can use the 5 2/3, or if you want to call it 17 thirds, either one of those will work as our solution. Let's look at example 2 now. We've got r minus 8 over 10 equals r over 2. Again, we would just simply cross multiply here. When we do r minus 8 and multiply it by 2, the 2 gets distributed to each piece. So we have 2r minus 16. r times 10 makes 10r. So this would be our equation at this point. Moving all the r's to the same side, we'll subtract 2r here and subtract 2r here. That's going to leave us with negative 16, because this is the minus 16. Negative 16 equals 8r. To get r alone, we divide both sides. Divide by 8. Divide by 8. Negative 16 divided by 8 becomes negative 2. So negative 2 equals r. This will be our solution. We double check. Can r equal negative 2? Well, r isn't in the denominator either case. So there is no excluded value. There's no spot where r can't be. So this is going to be a solution. R is going to be negative 2. That would be solving when they are proportions, so just one equal to another. There will be times when we have solving rational equations that have more than one expression on one side of the equation. There are a few steps to this, and it does take a little while. Some of these are a longer process. First, we need to find the least common denominator of all our denominators. The trick with this is you have to factor it first. Factor each piece. That'll help you find the LCD. Then we're going to multiply each term in our equation by that LCD. If you multiply it by the factors, it makes it much easier. Then, using those factors and your factored denominators, you can cancel out factors from the top and the bottom. They'll divide away. Step 4, solve the equation that remains in the numerators. The numerators will be the only thing left, so all you have to do is simplify them and then solve out the equation. In the end, you will might be left with more than one solution. That's okay. Just check each one to make sure that it is not an extraneous solution. So let's go through some of our examples. We'll see how this looks. Here we have 1 over 3n plus 1 over 2n squared equals 3 over 2n squared. Looking at our denominators, 3n, 2n squared, and 2n squared, we notice that our coefficients, there's a 3 and there's a 2. So we're going to need to include both of those as factors for our least common denominator. As well, all of these have an n in them. Now we don't want to include just n, we need to make sure we're looking at the highest power. This is n to the 1, n to the 2, n to the 2, so we need an n to the 2 to be part of our LCD. Now, 3 times 2 times n squared, our LCD is going to be 6n squared. This amount, 6n squared, is what we're going to be multiplying each term by. Now when you multiply each term by the 6n squared, it really only affects the numerator. So when we multiply the first one by 6n squared, we get 6n squared over 3n. When we multiply the second one by 6n squared, it stays 6n squared on top, because that times 1 stays itself, over 2n squared. And the last term, oops, there we go, turns into 18n squared all over 2n squared. Notice, none of the denominators change, we just multiplied each term by the same amount. Now, step 2, we can start canceling away any piece that is on top and on bottom. So in this one, n will cross out with an n, so it's no longer n squared, it's n to the 1. This 3 will cancel out with 3 from up here, so this one becomes 2. So this whole term is now 2n. Over here, n squared cancels with n squared, 2 cancels out with the 6, and we're left with a 3. This whole term just becomes 3. Over here, n squared and n squared, 18 and 2 will cancel out, and we're left with just 9. So, simplifying our equation down, we have 2n plus 3 equals 9, which is a much easier equation to solve than this one. From here, we just solve it how we normally would. Subtract 3, trying to get all the variables on one side, all the constants on the other. 2n equals 6. Now we need to divide by 2 on both sides, which means we're left with n equals 3. This would be our solution. We double check it up here. Extraneous solution here, n can't be 0, n can't be 0, and n can't be 0. This is not 0, so this will be our solution. N equals 3 will fit. It will work and make this equation true. Example 4, 1 over 6n minus 1 over n cubed equals n minus 1 over n cubed. So again, we're going to look for our coefficients. We have a 6 here. I'm actually going to break that up into 3 times 2. We'll break it down into kind of its prime factors there. 3 and 2. These each have an n in them as well. Like before, we're going to look for the highest power of n. This is n to the 1, n to the 3, n to the 3. So we need an n to the 3. So these are the factors, or these are the prime factors of our LCD. If we put it all together, it's 6n cubed. That's what's being multiplied by each piece. So this first term multiplied by 6n cubed So that goes up on the numerator, 6n cubed over 6n. Minus, we'll look at our second term, 6n cubed times our second term, we get 6n cubed over n cubed. Now we need to do 6n cubed times this term on this side, our third term. I'm going to leave it in factored form. I'm going to do 6n cubed times this n minus 1. Now, because I left everything in factored form, it'll make things easier to cancel out. 6 and 6 cancel out, n cancels out with one of these n's, so it's now an n squared. N cubed cancels out, so this one's just going to be 6. N cubed and n cubed cancel out, so this is just 6 and the factor n minus 1. So, simplifying our equation down, we'd have n squared over here minus 6 equals 6 times n minus 1. Distributing that 6 here, we'd get n squared minus 6 equals 6n minus 6. Now let's add 6 to both sides, get rid of these constants. Both of them will cross out, which means we're left with n squared equals 6n. We want to get everything onto one side then. So we'll subtract 6n, minus 6n on both sides. Now because this is n squared and this is just n, these will not combine. These are separate terms. So we have n squared minus 6n equals 0. Since we have it set equal to 0, we can do our zero product property. We'll factor it into n times n minus 6 equals 0, which means we've got two factors, here and here. When two things multiply to make 0, that means one of them has to be 0. How would we make this factor 0? Well, n would have to be 0. How would we make this factor 0? N would have to be 6. So our solutions are going to be n equals 0 or n equals 6. Let's double check those 0 and 6 to make sure they're not excluded values. For this numerator to be 0, we'd have to have n equals 0. So n cannot be 0. N can't be 0 here, and n can't be 0 here. So we know that n cannot be 0. When we solved it out, one of our solutions was n equals 0. So we have to get rid of that. We're not allowed to have n equal to 0 because we know that n can't be 0. So our only solution then is for n to be 6. This is the only number that's going to work to make this equation true. So n equals 6. Example 5. This one's going to take a little bit more time because we have to factor all of these pieces. So we're going to do that first before we start looking for the LCD. For this one, b squared plus 6b minus 16. Do your AC factoring and you get b minus 2, b plus 8. B squared plus 6b on bottom. Factor out a b and we get b times b plus 6. Looking at our second term, the top one just stays as 1. The bottom piece, we can take out a b and we'd get b plus 1. Now this one is a whole number, just 1, but you can call any whole number itself over 1. That'll give us a denominator to work with. Looking at all these denominators, we need to look for our factors then. b happens, b plus 6 happens, and b plus 1 happens. And technically we can say that 1 happens as well. We really don't need to include 1 as a factor though, because anything times 1 is just itself. So we'll leave that one out. But because b happened twice, we just need to mention it the one time here. We had another factor of b plus 6 and another factor of b plus 1. So, in a sense, these factors are what we're going to be multiplying by everything. Now, to give you a hint for the future, what this is going to be is actually b cubed plus 7b squared plus 6b. But when we multiply onto each piece, let's leave it as the factors. That'll help us when canceling everything out. So, canceling, or should I say multiplying first, this LCD onto each term, this first term becomes b minus 2 times b plus 8, that was what it was originally, times our LCD, b times b plus 6 times b plus 1. And it stays all over b times b plus 6. This second term is 1 times our LCD, b times b plus 6 times b plus 1. And it stays all over b and b plus 1. Our last term then, we have our 1 from before times the LCD, b plus 6, and b plus 1, and it stays all over 1. Now, we can start canceling. In this case, b cancels with b plus 6 cancels with b plus 6. In this case, b cancels with b plus 1 cancels with b plus 1. In this case, we really didn't even need the 1, but we can say that 1 cancels with 1. So, simplifying everything down, b minus 2 times b plus 8 comes back to b squared plus 6b minus 16. That was this piece originally. We're still multiplying that by this b plus 1. So when we distribute b times each of these things, it'll look something like this. b cubed plus 6b squared minus 16b. When we distribute 1 times each of these, it'll look like this. b squared plus 6b minus 16. That takes care of our first term. Now we need to add on the second term, which really the only thing left here is 1 times b plus 6, so it's just going to be that b plus 6. Looking over here, all we have left is the b times b plus 6 times b plus 1, which remember, that is our LCD. It's the b cubed plus 7b squared plus 6. So that's what we have at the end. Now, looking at our left side, let's start combining like terms. Here we see a b cubed, we see a b squared and a b squared. You see just b, and just b, and constant with constant. Combining all our like terms then. Our b cubed stay as just the 1b cubed. b squared, we had 6b squared and 1b squared, so we have 7b squared. For our b's, we have negative 16b plus 6b plus 1b, so we'd have negative 9b. And for our constants, we have negative 16 plus 6 becomes negative 10. All of this is still set equal to that LCD from before, so this is our equation at this point. Now we need to start subtracting or getting rid of some terms. If we take b cubed from both sides, so minus a b cubed, that'll cancel these out. If we minus 7b squared from both sides, that'll take both of those out. Now, let's add 9b to both sides. Adding 9b, we'll get rid of it over here. Add 9b, puts it all on this side. Oh, actually, so after all that canceling, we'd have negative 9b minus 10 equals 6b. Add the 9b to both sides, and we get negative 10 equals 15b. How do we get b alone at this point? Divide by 15 and divide by 15. Let's simplify as well. 10 over 15, we can take 5 out of each of those, so we'd have 2 over 3. And it's still a negative, so we have negative 2/3 equals b. This is going to be our solution. Now we still need to double check that negative 2/3 is not an extraneous solution. So in this case, actually, we'll use our factors. B can't be 0, b can't be negative 6. Neither of those are a problem. B can't be 0, b can't be negative 1. Neither of those are a problem. So negative 2/3 is our solution. Example number 6. Let's hold off on this one. We'll finish this in our next video.